Hey everyone, this is our lesson on limiting reagents, and by the end of this lesson you should be able to analyze the stoichiometric relationships inherent in a chemical reaction. We're specifically looking at how far a reaction can go. So before you get started, you may want to review chemical equations and stoichiometry. So let's talk about limiting reagents. Here are some definitions you just need to know. So a limiting reagent or a limiting reactant, they're the same thing, so you'll hear them either way, is a reactant that determines the amount of product that you form. So this is the one that you will run out of in a reaction. So if you've got a lot of reactant A and a little bit of reactant B to form AB, once you run out of B, you can no longer form AB, right? So your reaction has to stop. So if you look at this picture over here to the side, based on our ingredients here, we're making burgers. We've got 3 patties, 4 buns, 1, 2, 3, 4, 5, 6 pieces of cheese, and 1, 2, 3, 4, 5, 6, 7 tomatoes. Okay, or whatever that is. And we're going to make burgers that each have 1 patty, 1 bun, 1 piece of cheese, and 2 tomatoes, it looks like. So based on this information here, with the burgers or the patties, you can make 3 burgers, you can make 4, you can make 6, and you can make 3.5 if you put 2 on each. Okay, so when you do that, the one that you have the least of, which limits how many burgers you can make, only 3, that's your limiting reagent. Everything else, since you have stuff left over, would be, as we see now, your excess reagent. And the excess reagent or reactant is the one that is still present when the reaction is complete, so it's what you have left over. So based on the number of patties, you could only make 3 burgers. Well, when you only make 3 burgers, you have 1 hamburger bun left over, 3 pieces of cheese left over, and 1 tomato left over. None of that can make another complete burger, so our reaction is over. Okay. For these problems, you will need a balanced equation and a starting value for each reactant that you're looking at. So if you happen to only have, if you have 3 reactants, I may only be comparing 2 of them. You don't need it for all 3, but you do have to at least have 2 that you can compare between. So there are specific steps to use to solve for limiting reagent and product form. So a lot of times this is taught where, oh, I'll show you one side of that, or I'll show you one and then later teach you the other. I try to teach it all at one time because I feel like if you can kill 2 birds with 1 stone, why don't you go ahead and do that? So first, normally I'll give you grams of what you start with, or if I'm looking at 2 gaseous reactants, I'll give you liters. I try to give you the same unit. If I don't give you the same unit, you need to solve for the same unit at the end. Okay? So if I start you with grams of, grams of carbon, but I start you with liters of water, you need to solve for the same product in the same unit. Otherwise, you can't compare them. You've got to have the same unit at the end. That's the only way to compare which one made the most or the least. So if I give you grams of both, you'll take grams of each reactant, go to moles of those reactants, switch to moles of the product, and whatever unit of the product you want at the end. Okay. You need to look at the problem to determine the unit of the product. If I don't tell you what unit, I just say how much water is formed. Grams is always a safe option. Okay. But your pathway should basically look the same for both of these. You're always going to solve for the same unit and same product from each of your reactants. And you'll see this when I work through an example. Then you need to look at the amount of products that are calculated. Whichever one gives you the smallest answer, that is the maximum amount that can form, because after that you've run out of your other reactant. This is also referred to as your theoretical yield, which we'll talk about in the next lesson. And the reactant that formed the smallest amount of product is your limiting reactant. The one that formed more is your excess reactant or reagent. So sometimes I'll ask you what or how much of your excess is left over. That's not very hard to do. It's actually the reverse of what you're doing in this problem. So you're going to take the amount of product that you formed that you look at in step 2, and you're going to take that answer and work backwards and see how much of that excess reagent you needed to form that amount of product. Once you know how much was needed, you subtract that from how much I gave you in step 1, and the difference is how much is left over. So for instance, if we go back, or even if we look at this example here, let me X out of my picture so you can see it. If we look at this example here, to make s'mores, we need, if we have 27 pieces of graham cracker, we know they come with 2 pieces or 2 grams a piece. Then we know from there we can make 27 s'mores. Well, if you use, for some reason, 2 marshmallows for every s'more, and you have 40 marshmallows, you can only make 20 s'mores. So so looking at this, comparing your products, you would see that the limiting reagent would be the marshmallows, because you make less s'mores from the marshmallows, as you can see here, okay? So you make less s'mores, which means the limiting reagent is your marshmallows, because you compare these 2 numbers here, okay? Once you know that, then you can say, okay, well, my graham cracker is the excess reagent. I made 20 s'mores. So you would say, okay, 20 s'mores. To make that, I needed 20 graham crackers. Okay. I had 27. So you would do 27, which is your have, minus 20, which is your need. You have 7 left over. So that's how you would calculate your amount of excess left over, just as a basic example. So now let me work through this problem, and it's a lengthy one because I have a bunch of different steps to go through. But let's go through, this should say how, whoops. Let's go through all of this. So we're looking at grams of NH3 is what we want from a reaction that used 5 grams of N2 and 5 grams of H2. We want to know which one is the limiting reagent, and we want to know how much excess is left over. So we're actually solving for 3 things here. And I did not give you a balanced equation to start with. However, we did look at this one in a previous lesson. So it would be N2 plus 3H2 yields to, sorry, this is getting sloppy, guys, NH3. So now that we know that, we can look at our steps here. So for both of these, we're going to go grams of N2 to moles of N2, because we need to change products, to moles of NH3. And based on this problem, it said grams. So we're going to go to grams of NH3 on both of these. Okay, so that's our first pathway. And our second one, the only thing that changes is we're starting with H2. We're going to still go to moles of NH3 and grams of NH3. So first, until you get used to doing these types of problems, I really want you to write the pathway out. Because when you come to me because you missed a question or you want to ask for help, I'm going to ask you first, what is your pathway? So now that we have that, let's go ahead and start working through these. So we have 5 grams of N2. And as you'll see, I'm going to work through the H2 very quickly because it's going to look exactly the same. We got N2 on the bottom, moles, N2 up top. Comparing mole to a different unit, so we've got 1. For every 1 mole of N2, there is 28 grams of N2. We're going to cancel those units. Okay, now we're going from mole of N2 to mole NH3. I'm mole over mole. Those values come from the balanced equation. Okay, so those are going to cancel. Now we're in moles of NH3. We want to get rid of those. Grams of NH3. For every 1 mole of NH3, there's 17 grams. Get rid of the moles there. Multiply everything up top. Divide just by 28. So my answer here would be, let me multiply this out very quickly. If I multiplied it out correctly, it should come out to 6.07 grams of NH3. You're going to basically do the same thing for this one. Again, you're starting now with 5 grams of H2. Going to get rid of 1. Nope, just kidding. 2 grams of H2 for every 1 mole of H2. This is why I always write the units first. You see I messed up there. Mole of H2 to mole of NH3. I mole over mole. It's 2 moles of NH3. 3 moles of H2. Let's start canceling some stuff out. And then we go from our mole of NH3. 2 grams of NH3. For every 1 mole of NH3, there is 17 grams. And as you can tell, I'm going to just kind of show you this. This part of your, both of your equations should look identical because you're doing the same math at the end. So again, you're going to end up multiplying through, doing everything that you need to. 5 times 2 times 17 divided by 2. So we actually would make, based on this number, 85 grams of NH3. So now that we have these two values, we need to just look at these for comparison, and we look for the one that gives us the smallest product. Well, it's very clear that this 6.07 grams of NH3 is less product. So this is how much will form. We got the first question answered. We also know which one is our limiting reagent, which would be the 5 grams of N2 because it gave us the 6.07 grams of NH3. So I want you to pause the video, make sure you write down everything I've got here. I know it's sloppy, I'm sorry, but I need to clear my screen to work on the next part. All right, so we need to now figure out, we're looking at how much excess is left over, okay? So we know that our product formed that we had was 6.7 grams of NH3. So now my pathway is grams of NH3 to moles of NH3 to moles of H2, because that was our excess, to grams of H2 specifically needed. Okay, so we're going to write this one all the way through. These are long problems. They take a lot of space, so just be prepared for that. So we're going from grams of NH3 to moles. 1 mole for every 17 grams. Get rid of our unit there. Then we're going from moles of NH3 to moles of H2. I mole over mole, so we get them from the balanced equation. Okay. And then we go from, no, it's not going to work. And then we go from moles. Hold on, my pen decided it didn't want to work anymore. Give me a second. It will work now? No. Of course, right in the middle of a math problem, my little stylus decides to not work. There we go. So then we go from moles of H2 to grams of H2, and we use grams of H2 because we were given grams in the original problem. So 1 mole of H2 is always 2 grams of H2. Cancel our units there. And we're going to start doing some math here. So 6.07 times 3 times 2, okay, divided by 17. So we needed 2.14 grams of H2 to form our 6.07 grams of NH3. So now that we know that, this is how much was needed. So we had 5 grams originally. We're going to subtract the 2.14 from it, and that would be that we have 2.86 grams left over. So like I said, I know these are long problems, amount of work for you to do, but it's good to understand. So pause the video, write this down because I'm going to clear my screen. And now I want you guys here at the bottom, I want you to try this one. I did not give you a balanced equation, but I did give you the formulas for everything. So balance first and then go through your steps. Here, you do not have to tell me how much excess